Now in order to complete this table, naturally we have to find all these entries, but it is not possible for me to do it here due to time constraint. So what I will do is I will do few calculations, and rest of the calculations I leave it to you. So first of all I will find R90 composition R180 right over here, and next I will find R180 composition D, and afterwards I will do these two calculations. So first of all, for R90 composition R180, now in order to find this, remember we have to operate this on our square 1, 2, 3, 4, right? The basic square you can call it as. Now after operating R180 on this square, we get this square. Now this you already have on this side, you can call it as a table. So you can see here, if we operate R180 on this square, that is what we get. So I have written that square here. Now we have to find R90 of this. Now in order to find R90 of this square, we have to do the calculations. Now what calculations we have to do? What R90 says is कि whatever square we have, you just rotate it by 90 degrees in anti-clockwise direction. So now we have to rotate this square in 90 degrees in anti-clockwise direction. So you will see that this 3 will come here, right? So this 3 will come here, this 2 will go here, this 1 will go up, and this 4 will come here. So this square we will get. Now you have to search where does this square lie on this side. So let us search where does it lie. Yeah, I can see it is here. So basically this is nothing but R270. So what should I write here? R270. Now similarly, let us do calculations for this. Now what we have to do is, again I have written our square 1, 2, 3, 4. Now you have to operate D on this square. Now the answer lies in this table only. As you can see, if we operate D on this square, we get this square. So let us write it there. So this is equal to R180 of, this one. So 1, 2, 4 and 3. Now what we will do is, as the job of R180 is to rotate in anti-clockwise direction by 180 degrees, so we will do the same thing to this square. Now the real calculation lies here. So how to rotate it? So first of all, I will shift this 1 here. So this is a rotation by 90 degrees, right? Now if I shift 1 here, right, by 2 position, it means that I am doing the rotations in anti-clockwise direction, right, by 180 degrees. So I will write 1 here. Similarly, by doing rotation by 90 degrees, I will have 2 here. Again by doing it by 90 degrees, I will have 2 here. Similarly, you can write rest of the entries. So 3 will come here and 4 will come here, right? Now you have to search where does this square lie on this side, right? And I can see that this is that square and this is nothing but actually D dash. So over here we are going to get D dash. Now for doing these calculations, we have to operate R270 on this square. But if you operate R270 on this square, what do we get? Yeah, this square. So I will write it as it is. So it will be V of this square, that is 1, 2, 3 and 4. Now we have to operate V on this square, but what is the job of V? Rotation about vertical axis. So we have to rotate this square around vertical axis. So this entries, right, these entries on this side will go there and this will come here. So it will be 1, 2, 4, 3. Now we have to search for this square on this side. So where does it lie? I can see that it lies here, and this is actually nothing but D. So this is actually D. So I will write it here. Next, again we will operate V on this square, and we already have that answer. It is here. So I will write this square as it is 1, 4, 3, 2. Now we have to operate D on this square right here. In order to do it, what is the job of D? The job of D is to rotate the square around the main diagonal. So this is our main diagonal, right? So we have to keep this 2 and 4 as it is, and these two entries will be interchanged. So this will be 3, this will be 1. Now we will search for this square on this side, and where does it lie? Yes, somewhere here, and that is nothing but R90. So this is nothing but R90. So in this way you can do the calculations and you can complete the composition table. Now once the table is completed, we have to check all the conditions of the group. So we know the first condition of the group is that the set should be non-empty. Whatever set we are checking, whether it is a group or not, that should be non-empty. So which is our set in this case? We denote group of symmetries of a square by D4, and this set contains these 8 elements: R0, R90, R180, R270, H, V, D and D dash. Now clearly the set is non-empty, no issues with that. Now the next condition says that the composition should be a binary operation on this set, right? And in order to check it, we have to see entries of the table. So all the entries of the table are from this set itself. Therefore composition is a binary operation on D4. No issues here. Again, for associativity, we know that composition of functions is always associative. So this property is also satisfied. Next comes out to be existence of identity. So from the table we can observe that. So in order to find the identity element, we have to see whatever this first column you can see on the extreme left, this should repeat as it is in the table in order to search for identity element, and you can see that it lies here, right? And what is the corresponding element? R0. Similarly, this first row should repeat as it is in the table, and you can see that it is repeated here, and the corresponding element is R0. Thus R0 satisfies our requirements, and thus R0 is the identity element of the group D4. Now talking about existence of inverse, that also can be checked easily. So in the row of R0, just look where does R0 come. It is here, and look for the corresponding element. So R0 inverse is R0. Next, if we want to search for inverse of R180, just check what is R180. So in the row of R180, just search for R0. It lies somewhere here. So R180, composition R180 comes out to be R0. Thus inverse of R180 is R180. Now in order to find the inverse of R90, we have found out inverse of R0 and R180. So in order to find the inverse of R90, simply see the row of R90. You can see that R0 lies here. Basically, in order to find the inverse of each and every element on this side, just we have to see in that particular row where does R0 lie. So in the row of R90, we can see that R0 comes out to be here, see the corresponding element, that is R270. So what do we have? R90 composition R270 is actually R0. But remember, we cannot conclude here that R270 is the inverse of R90, because what does the inverse property say? For each A belongs to G, there should exist A inverse belongs to G such that A inverse should be E, which is further equal to A inverse A. That other way round should also happen. So now we have to check whether R270 composition R90 is also R0. So where does R270 lie? Somewhere here. So composition of that with R90, right? So R270 composition R90, what is that? Yeah, that is also R0, as we can see from the table, right? Thus, now we can conclude that R270 is the inverse of R90, and thus R90 inverse exists, and that is actually nothing but R270. Similarly, you can verify that the inverse of R180 is R180. Actually, we have already written here. Next, inverse of R270 will be R90. Next, the inverse of H will be H itself. Next, the inverse of V will be V itself. The inverse of D will be D itself, and the inverse of D dash will be D dash itself. Thus, inverse of each element exists in D4, and therefore D4 is actually a group with respect to composition of functions. That is nothing but group of symmetries of a square is a group with respect to composition of functions. Now the question is it abelian? Now in order to check it, we have to see whether this table is symmetric or not, and that part I leave it to you.